The night shift at Consolidated Machine Works ends at 11:40. By 11:30, the firebox dampers are closed, the steam valves drawn down to their seats, and the main drive engine, a 40-ton horizontal compound built in 1881, begins its deceleration into stillness. Thomas Brennan, night foreman, watches the flywheel. 15 feet across, cast iron, spoked like a locomotive driver. It completes one rotation every 2 seconds now, then 3, then 5. The leather belts overhead go slack against their pulleys, no longer taut with the tension of work. The smell of hot oil begins to fade, replaced by the cooler air drawing in through the loading doors. The flywheel stops. Brennan marks the time in his ledger, 11:43. He hangs his lantern on the beam post and walks toward the tool room, boots echoing on the brick floor. Behind him, the engine settles. Cast iron ticks as it cools. Steam lines pop softly in their hangers. The building exhales. Then, underneath the silence, something else begins. A whisper, metallic, faint enough that Brennan stops mid-stride and tilts his head, uncertain if he heard anything at all. He listens. The whisper continues, not rhythmic, not quite musical, but persistent, like wind through a narrow gap, except there is no wind. The loading doors are closed. The draft dampers are shut. Brennan walks back to the engine. The flywheel is motionless. The crosshead sits dead center in its guides. Nothing moves. But the whisper remains, soft as breath, emanating from somewhere within the iron framework of the machine itself. He listens for another 30 seconds, then shakes his head and leaves for the night. The whisper does not stop. By the following night, 3 other men have heard it. John Wickham, the oiler, arrives at 5:30 to grease the bearings before the evening run. The engine has been cold for 18 hours. He climbs the access ladder to the main bearing housing, oil can in hand, and pauses. There it is again, that faint metallic hum, like a tuning fork struck an hour ago and never quite fading. It seems to come from the pillow block, or perhaps the bedplate beneath it, or maybe the floor itself. Wickham crouches and places his palm flat against the cast-iron frame. He feels nothing, no vibration, no warmth beyond the ambient temperature of the room. He presses his ear to the metal. The whisper is clearer here, still soft, but unmistakably present. A sustained tone with the faintest modulation, rising and falling over the course of seconds. He mentions it to Brennan when the foreman arrives. "You heard it too, then," Brennan says. "Thought maybe a steam line wasn't fully isolated," Wickham says. "But I checked, everything's cold." Brennan nods slowly. "It started last night, right after shutdown." They stand together in the dimness, surrounded by the silent machinery. Overhead, the belt lines hang in loose curves. The tool benches are covered with a thin film of metal dust. A single lantern burns near the door, casting long shadows that stretch across the floor like fingers. And beneath it all, the whisper continues. Samuel Cobb, the machinist's apprentice, joins them. He's 22, sharp-eyed, curious. "What are we listening for?" "You don't hear that?" Wickham asks. Cobb frowns, listens, then his expression changes. "There, yes, what is that?" "We don't know yet," Brennan says. The 3 men spread out across the floor, moving slowly, trying to locate the source. Cobb kneels beside the flywheel pit. Wickham climbs back up to the bearing platforms. Brennan circles the boiler connections, checking each flange, each valve, each junction where metal meets metal. The whisper is everywhere and nowhere. It doesn't grow louder near any particular component. It seems to inhabit the entire structure, walls, floor, framework, as if the building itself were the instrument producing the tone. "It's like it's coming through the foundations," Cobb says. Brennan doesn't answer. He's thinking about something else now. The engine has been in this building for 4 years. It has stopped thousands of times. This has never happened before. By midnight, the whisper has changed. What began as a soft, sustained tone has developed rhythm. Not a mechanical rhythm, not the regular ticking of a clock or the pulse of a piston, but something more complex. A pattern of rises and falls, crescendos and diminuendos, like breath, like speech in a language no one understands. Brennan feels it now, not just through his ears, but through his body. A faint pressure in his chest, a sense of resonance in his sternum, as if he were standing too close to a large bell that had just been struck. He shifts his weight and feels the vibration transfer up through the soles of his boots. The floorboards are moving, not visibly, not enough to see, but enough to feel. Wickham stands with one hand pressed against the main bearing column. "It's stronger now," he says quietly. "The metal's singing." Cobb has moved to the far end of the shop, near the line shafts. He crouches low, ear tilted toward the brick floor. "I can hear it through the ground," he calls back. "It's traveling through the foundation." Brennan walks the length of the engine bed, watching for any sign of movement. The flywheel remains perfectly still. The connecting rod rests in its lowest position, oil pooling in the crank pin bearing. The piston is motionless inside the cylinder, the valve gear locked in neutral. Every component is exactly where it should be. But the structure around them continues to hum. It's not unpleasant exactly, not loud. If you spoke in a normal voice, you could be heard clearly. But it's unsettling in a way that's difficult to articulate. The machine has stopped, but something about it has not ceased. Some residual energy, some tension in the metal or the air or the space between them is still active, still present. Wickham looks at Brennan. "Should we start it back up, see if that stops it?" Brennan considers this. "No," he says finally. "We need to understand what's happening first. If we run the engine now, we might make it worse." "Worse how?" "I don't know. That's the problem." They continue listening. The rhythm persists. A 3-second rise, a 2-second plateau, a 4-second fall, then again, and again. The pattern is irregular enough that you can't predict it, regular enough that you know it's not random. Cobb stands and walks toward them, his face pale in the lantern light. "It feels like the building's breathing," he says. Brennan doesn't disagree. By 2 in the morning, they've disassembled half the accessible engine components. The bearing caps are removed, revealing the brass journal surfaces beneath. No scoring, no heat discoloration. The oil film is intact, cold, undisturbed. Wickham runs his fingers along the journal, smooth as glass. The crosshead guides are inspected next. No wear, no misalignment. The jibs are tight, properly shimmed, exactly as they were set 3 months ago during the last maintenance cycle. Brennan climbs into the flywheel pit with a pry bar and checks the spokes for cracks. Cast iron is brittle. Sudden thermal stress can fracture it without warning. He taps each spoke with the steel bar, listening for the clear ring of solid metal. Everyone responds perfectly. No dead tones, no hidden flaws. The whisper continues above him. Cobb examines the belt connections. 36 leather belts run from the engine's main pulley to the overhead line shafts. Each belt is 3 inches wide, stitched and riveted, treated with beeswax to reduce slip. He loosens each one in turn, letting them hang completely slack. The whisper doesn't change. "It's not the belts," he reports. Wickham moves to the boiler end. The steam pipes are cold now, cold enough that condensation has formed on their outer surfaces, dripping slowly onto the brick below. He opens the drain cocks one by one, releasing the residual water trapped in the low points. Nothing but a trickle. No steam, no pressure. The boiler has been isolated for hours. Brennan rejoins them, wiping oil from his hands. Main bearings are perfect. Flywheel is solid. No cracks, no looseness, no bearing shift. "Then what's making the sound?" Wickham asks. Brennan looks around the shop. The walls are brick, 18 inches thick, built to withstand the vibration of heavy machinery. The floor is brick laid on compacted earth, with cast iron rails embedded every 12 feet to support movable equipment. The roof is timber frame, open truss, with skylights that rattle slightly in winter wind. But tonight there is no wind. "I think," Brennan says slowly, "it's not coming from the engine itself. I think the engine is responding to something else." Responding how? Cobb asks. I don't know, but nothing we've found explains this. Every part is exactly as it should be. The machine is completely stopped. There's no energy source, no steam, no rotation, no pressure. And yet, he gestures toward the framework. The whisper continues, soft and persistent, filling the space between words. Wickham leans against the main column, arms crossed. So, we're saying the engine's haunted then? No, Brennan says firmly. We're saying we don't understand it yet. They stand in silence for a moment, listening. Then Brennan makes a decision. We document everything. Temperature, time, position of every valve and lever. We don't change anything else tonight. We watch, and we wait. Over the next 3 nights, they try everything they can think of. First, complete isolation. Every remaining connection between the engine and the building systems is severed. The exhaust vent is disconnected. The condensate return line is unbolted. The steam supply line is physically separated at the flange, leaving a 6-inch gap. The engine sits now as an island, connected to nothing but the foundation it rests on. The whisper continues. Second, lubrication. Perhaps some bearing surface, despite visual inspection, is experiencing microscopic friction. Wickham floods every journal, every bushing, every pivot point with heavy machine oil. He fills the oil reservoirs to capacity. He applies graphite paste to the crosshead guides. The metal gleams wet in the lantern light. No chain. Third, ventilation. Cobb suggests that pressure differentials in the building might be creating the sound, air moving through some narrow gap in the structure. They open the loading doors at both ends of the shop. Cold autumn air floods in, equalizing the pressure. They leave the doors open for 2 hours. The whisper remains constant. Fourth, belt removal. Although the belts are already slack, Wickham suggests removing them entirely. It takes most of a night to unbolt all 36 belts from their pulleys and coil them on the floor. The overhead line shafts now spin free, unconnected. The engine's main pulley sits bare, its rim gleaming in the lamplight. The sound does not diminish. Fifth, mechanical damping. Brennan orders sandbags placed around the base of the engine, thinking perhaps to absorb whatever vibration is traveling through the floor. They stack 200 pounds of sand in canvas sacks against the bed plate. The floor around the engine becomes a barrier of dead weight. The whisper ignores it entirely. By the 5th night, the men are exhausted and baffled. They've eliminated every conventional source. No moving parts, no air pressure, no steam, no friction, no loose components. The engine is as inert as a piece of architecture, and yet it continues to emit this faint, persistent, rhythmic tone. Brennan sits on an overturned crate, writing notes by lantern light. He's documenting everything just as he promised. Temperatures, humidity, wind, direction, time of day, barometric pressure from the dial in the office. There has to be a pattern, he says, more to himself than to the others. Nothing happens without cause. Wickham lies on his back beneath the main bearing, staring up at the underside of the bed plate. Maybe it's just the metal settling. We're hearing it cool down. Thermal contraction. For 5 days straight, Cobb says, at the same intensity. Wickham has no answer. Brennan continues writing. Outside, through the open loading doors, the first grey light of dawn is beginning to show. The shop will start up again in 3 hours. The engine will be fired, brought up to pressure, and set to work turning lathes and drill presses and punch frames. And when it runs, the whisper will disappear beneath the roar of steam and steel. But tonight, when it stops again, the whisper will return. Brennan knows this now, with certainty. At 3:15 in the morning on the 8th night, Samuel Cobb makes the discovery. He's sitting near the loading door, back against the brick wall, half asleep. The whisper has become so familiar now that he barely registers it, just part of the background, like the distant sound of the city beyond the factory walls. But something changes. A momentary surge in the tone, a brief crescendo that pulls him fully awake. He sits forward, listening intently. 30 seconds later, it happens again. A definite increase in amplitude, lasting perhaps 3 seconds, then fading back to the baseline hum. Cobb stands and walks toward the engine, trying to locate the source of the change. But before he reaches it, he hears something else, the distant sound of a train whistle. 2 long blasts, far off to the northeast. He stops, waits. A minute passes, then another surge in the whisper, and simultaneously, the low rumble of a freight train passing on the elevated tracks half a mile away. Cobb's eyes widen. He turns and runs to find Brennan. "The railway," he says breathlessly. "It's the railway." Brennan, dozing at his desk in the tool room, looks up. "What?" "The whisper. It gets louder when trains pass. I just heard it happen twice." Brennan stands immediately. They return to the shop floor together. They wait in silence. 3 minutes, 4, then, distant but unmistakable, another train whistle. And moments later, the whisper swells briefly before subsiding. "God in heaven," Brennan whispers. "It's transmitting through the ground." They spend the rest of the night testing this hypothesis. Cobb takes up position near the loading door with a pocket watch, timing every train that passes. Brennan stands beside the engine, listening for changes in the whisper. Wickham, roused from sleep, joins them with a notebook, recording each observation. By dawn, the pattern is undeniable. Every train that passes within a certain distance, roughly a half-mile radius, produces a corresponding fluctuation in the whisper. Freight trains create longer, slower pulses. Passenger trains create sharper, shorter spikes. The timing matches perfectly. But this only explains the variations in the sound. It doesn't explain the sound itself. "The tracks are on elevated timber trestles," Wickham says. "No direct connection to our foundation." "No direct connection we can see," Brennan corrects. "But foundations go deep. Bedrock is 30 feet down in this district, if both the railway and our building are anchored to the same geological layer. Then vibration could travel through the earth itself," Cobb finishes. Brennan nods slowly. The engine is a receiver, a massive iron structure, precisely balanced, sitting on a foundation that connects it to the vibrations of everything around it. When it's running, its own motion overwhelms any external input, but when it's stopped, it becomes a listening device, Wickham says. They stand together in the grey morning light, watching the silent engine. The whisper continues, soft and persistent, carrying within it the distant rhythm of the city's industrial heartbeat. 23 years later, in 1907, a mechanical engineer named Douglas Fairchild publishes a paper in the Transactions of the American Society of Mechanical Engineers titled Structural Resonance and Harmonic Coupling in Large Stationary Engines. In it, he describes the phenomenon observed at Consolidated Machine Works, along with 3 similar cases documented at other facilities. His explanation is precise and unambiguous. The whisper, he concludes, resulted from a convergence of 5 separate mechanical principles operating simultaneously. First, thermal contraction. When the engine stopped, its cast iron frame began cooling at a rate of approximately 2 degrees per hour. Cast iron has a coefficient of thermal expansion of 6 millionths per degree Fahrenheit. For a structure weighing 40 tons, this produced a cumulative contraction force of over 8,000 pounds, distributed across the frame and bed plate. This contraction created residual tension in the metal, a stored elastic energy seeking equilibrium. Second, harmonic coupling. The engine's natural resonant frequency, calculated from its mass and the stiffness of its mounting, was approximately 18 Hz. This happened to coincide with the dominant frequency of vibrations transmitted through the district's bedrock from railway traffic. The engine, though motionless, was being excited at its resonant frequency by external sources. Third, acoustic standing waves. The shop building itself acted as a resonant cavity. Its dimensions, 200 feet long, 60 feet wide, 30 feet high, created natural acoustic modes at specific frequencies. When the engine vibrated, even minutely, it drove these standing waves, amplifying certain tones while suppressing others. The resulting sound was not generated by any single component, but by the interference pattern of multiple reflections within the enclosed space. Fourth, frictional modulation. Although the engine was not rotating, microscopic movement was occurring at every bolted joint, every fitted surface. The thermal contraction created shifting load distributions. These shifts produced stick-slip friction at microscopic scales, vibrations too small to see but sufficient to generate acoustic energy in the audible range. Fifth, structural transmission. The building's foundation was continuous brick and stone, extending 30 feet to bedrock. This created a direct mechanical path for vibration from distant sources. Railway traffic, street traffic, other machinery in neighboring buildings all contributed low-frequency vibration that propagated through the ground. The engine, by virtue of its mass and mounting, acted as a transducer, converting these structural vibrations into airborne sound. Fairchild's paper includes detailed calculations. He demonstrates that the whisper required no supernatural explanation, no mysterious energy source. It was simply the complex interaction of physical systems operating exactly as the laws of mechanics predict. But he also notes something else in his conclusion. He writes, "The phenomenon persists only so long as the structure remains in a state of thermal disequilibrium and external excitation continues. It is self-limiting and ultimately temporary. Yet to the workers who first experienced it, the sound must have seemed inexplicable, evidence of hidden forces within the machine itself." He's right. To Brennan and Wickham and Cobb, standing in that dim shop in 1884, the whisper was inexplicable. They lacked the analytical tools to decompose it into its constituent causes. They could only listen and wonder. The engine at Consolidated Machine Works was eventually replaced in 1909 with a more modern design. The building was demolished in 1923. No record exists of whether the new engine exhibited similar behavior. But Fairchild's paper remains, a careful dissection of a mystery that was never truly mysterious, only poorly understood. There's something about large machines that makes them feel alive. It's not superstition, exactly. It's the accumulated experience of working alongside something massive, hot, powerful, and capable of crushing you if it fails. You learn to read its behavior, the sound of its breathing, the smell of its heat, the vibration through the floor that tells you when bearings are running true or beginning to fail. So when a machine begins making sounds it shouldn't, your body responds before your mind does. Your chest tightens, your attention narrows. Because in your experience, machines only make unexpected sounds when something is wrong. And when something goes wrong with 40 tons of pressurized iron, people die. Brennan and his crew were responding rationally to an irrational situation. The engine was behaving in a way that violated their accumulated knowledge. It was stopped, cold, isolated, and yet it was producing sustained acoustic output. By every rule they knew, this should not happen. The whisper felt alive because, in a sense, it was. Not biologically alive, but dynamically alive. A system in motion, responding to inputs, generating outputs. The engine had become part of a larger mechanical ecology. The railways, the neighboring factories, the street traffic, the geological substrate, all were connected through vibration, through the transmission of energy through solid matter. The engine was simply the most sensitive instrument in that network, the one that made the invisible visible, the inaudible audible. Fairchild understood this. His paper is not dismissive. He doesn't mock the workers for being mystified. He recognizes that they were encountering a genuine edge case, a situation where intuition failed because the phenomenon existed at scales they couldn't directly perceive. Modern engineers, with accelerometers and frequency analyzers and finite element models, can predict such behavior. They can calculate resonant frequencies before a machine is built. They can isolate structures from ground vibration using spring mounts and damping systems. The whisper would never persist in a modern facility. But in 1884, in a brick building with a cast-iron engine bolted directly to a stone foundation, in a city dense with railways and factories and traffic, the conditions were perfect. The phenomenon emerged naturally from the environment. It required no special circumstances, no rare malfunction. It simply required a large, precisely made machine, allowed to stop in silence, in a place where the ground itself was humming with the energy of industry. The whisper was the sound of the industrial age talking to itself, machines speaking to machines through the bedrock, the city's metabolism made audible. And for 8 nights in October 1884, 3 men stood in a darkened shop and listened to a conversation they were never meant to hear. The engine whispered, and then, eventually, it stopped. Not because anyone fixed it, not because some component was adjusted or replaced, but because winter came and the ground froze and the transmission of vibration through the earth changed character. By December, the whisper was gone. The engine ran for 25 more years. It never whispered again. But Brennan kept his notes, and decades later, those notes reached Fairchild, who understood what they meant, who could translate sensation into mathematics, mystery into mechanism. The whisper is explained now, documented, understood. But late at night, in old buildings where heavy machinery sits silent, workers still listen. Because sometimes the machines do speak. And sometimes what they say is true.